All right, here's your Chapter 5 practice test. Number 1, find the real solutions of the equation. Round your answer to the nearest hundredth. 12x raised to the fourth power is equal to 78. So remember on this one here, we're going to first divide both by 12. So I'll get that x raised to the fourth power is equal to 78 divided by 12 will give you 6.5. Now remember, to get rid of a power, you take the root of that power. So we have the fourth power there. So we are going to take the fourth root. So we're going to say that x is equal to, and remember, since it's to the fourth root, it's an even root. You're going to say plus or minus, and then you're going to take the fourth root of 6.5. If we take the fourth root of 6.5 and you plug it into your calculator, again, you're going to get plus or minus. We're going to put that in on our answer, and we'll have 1.59672. Now, remember, your big ideas will mark this wrong if you don't round it to the nearest hundredth. So remember, the nearest hundredth is 2 decimal places, so that means we would be going here. So I look at the one to the right of it, that is 6. So that means I'm going to change the 9 to a 0, and then I'm going to change the 5 to a 6, so 1.60, and that'll be the answer. They already have the plus or minus there for you, so you don't have to worry about putting it in here if you have one that is to an even power. If it's an odd power, remember, it doesn't matter. It can go ahead and be a negative underneath the radical. Number 2, evaluate the expression without using a calculator. Well, remember, if it's to a negative power there, like this one is here to the negative 2/3, that means that we can go ahead and write it down as 1 over 125 raised to the positive 2/3 power. So we can simplify that by taking, remember, that 3 means it's going to be the fifth root. So if the third root, not the fifth root. So if we take the cubed root of 125, and then we can square that, all right, the one's going to stay up on the top. Well, the cubed root of 125 is 5, so we're going to have 5 squared, and we know that 5 squared is equal to 25. So our answer will be 1/25. Number 3, use the properties of radicals to simplify the expression. So on this one here, if you kind of look at it, we have the 6th root here, we have the 6th root here. So what we should probably do is see if we can find out if 320 is divisible by 5, because then we can bring them up together. So if that's the case, then I'll have the 6th root of 320 divided by 5. Well, 320 divided by 5 is 64. So if we take the 6th root of 64 and plug that into our calculator, we'll find that it is equal to 2. Number 4, write the expression in simplest form. Remember, on these ones here, we can't have a radical in the denominator. So I'm going to take and multiply the top and the bottom by 2 plus the square root of 7. So when I do that, then I'm going to have a difference of squares on the bottom. So remember, what I mean by that is, since I have 2 minus root 7 times 2 plus root 7, I can go ahead and multiply the first terms together, which will give me 4 minus, because it's going to be a difference of squares. And then remember, I can square those two right there. Well, the square root of 7 squared will just be 7. So So let me actually put it right there. All right. And then on the top, we have 3 times 2 plus the square root of 7. Now, before we distribute that 3 through, what you should recognize here is that I'll have 3 times 2 plus the square root of 7 on the top. On the bottom, I'll have 4 minus 7 is negative 3. So if we look there, our 3's are going to cancel. So now I have a negative on the bottom. So I'll just distribute that negative through everything on the top. So what that is telling us is that we're going to have and change the sign of everything. So the 2 is going to become negative. That root 7 is going to become negative. And there is your answer. Okay. Number 5, write the expression in simplest form. It's telling us to assume all variables are positive. So what you need to do here is you need to take the numbers and you need to take the variables. And let's go ahead and do one each separately. So if I take the numbers, I'll have the 4th root of 48. All right, we've done this a couple of times, so we should be able to recognize that I can write that as the 4th root of 16 times 3. When I, excuse me, when I take that, I can do the 4th root of 16 times the 4th root of 3. Notice how I separated them. And the 4th root of 16 is 2 times 2 is 4, times 2 is 8, times 2 is 16. So we can write that one as 2. And then we're going to have the 4th root of 3. All right. For A, if I look at A there, again, I find it easier to just put it in fraction form. Remember, I have A raised to the 4th power. Remember, I can write the 4th root of something as a variable raised to the 1 over 4 power, or we're going to have 4 over 4. Well, 4 over 4 is just going to be 1. So A will be on the outside, and it'll be 1. Same thing when I look at my B there. When I look at my B, I'm going to do the same thing here. I'm going to write it as 5/4. Okay, so now remember, I can rewrite that if I have to as B to the 4/4 plus 1/4. So B to the 4/4 will just be B, just like I just showed you with A, but the B to the 1/4, we're going to rewrite that as the 4th root of B. And then finally for C in this case, when we see C, we're going to say that is 8 over 4. Well, 8 divided by 4, is 2. So that one will be C squared. So anything that's not underneath the radical now, I keep on the outside. So based on what I just told you, we're going to keep the 2 on the outside. We're going to take the A on the outside. This B right here is going to go on the outside. And then we have C squared. Anything that's still underneath the radical, and in this case our radical is to the 4th, we're going to put together again. So we'll have 3 and we'll have B. And that is your final answer that you will put in. Number 6, simplify the expression. So on this one here, if you notice we have root 2 there. We have root 8 here. If we can make that root 8 be 2, then we can add them together. So if I look at that one there, I can say that 2 times the square root of 8, well, we know that the square root of 8 we can write as the square root of 4 times the square root of 2. So that'd be 2 times the square root of 4 times the square root of 2. You know that the square root of 4 is 2. So I'll have 2 times 2 times the square root of 2, which is just 4 times the square root of 2. So now I do have it as the square root of 2, so I can have 6 root 2 plus 4 root 2. And when I work that out, now I can just add the numbers in front. So I'll have 10 root 2. Number 7. Again, we've been doing these transformations for a while, ladies and gentlemen, so hopefully we can start seeing what happens here. So let the graph of G be a vertical stretch. Remember, vertical stretch is now on the outside by a factor of 3. So that's the first thing we're going to do. And then we're going to follow by a translation 2 units left of the graph of f of x is equal to 2 root x minus 1. So we're going to write a rule for G. So we're going to start with h of x, only because that's kind of what your book likes to do. I keep telling you that. So we're going to take our h of x, and on this one here, we're going to take our factor of 3, since it's vertical, it's on the outside, and we're going to multiply it to what our f of x is. So our f of x there is actually 2 times the square root of x minus 1. So now in this, we are going to distribute that 3 through the parentheses. So 3 times 2 is 6. So I'll have 6 times the square root of x minus 3. That is our h of x. Now our g of x is asking us to do 2 units to the left. So we're going to say g of x. And here, let me go back to that color I was using, green. So we can say that g of x is now going to be h. Remember, left to right means I'm going to attach it to the x. So my x that I have, I'm going to attach a 2 to it. All right? So what that is saying, I have my 6. Sorry, I started looking at it up above. So I have my 6. All right? I just told you my x, I'm going to attach a 2 to it because it's left and right. And then I still have my minus 3 there. And that right there, ladies and gentlemen, is the answer you're going to put in Big Ideas. Number 8 is a word problem. And the word problem, it may sound daunting, but it's really not. The speed s in miles per hour, so that's our hint, is of a car driving on dry asphalt can be given by s is equal to 4.74 times the square root of d, where d is the stopping distance in feet. What is the approximate stopping distance? So that's the one we don't know, of a car traveling 55 miles per hour. So 55 miles per hour, that's telling us that is our S. So if that is our S, what we're going to have to do here, ladies and gentlemen, is we're going to have to solve for D. So we're going to take our 4.74 times the square root of D is equal to, well, our S is now 55 miles per hour. So as you can see, what we're going to do here is we're going to solve for D. So the first thing I'm going to do, I'm going to divide both sides by 4.74. And when I do that, I will get that the square root of D is equal to 55. And I would just keep it like this for right now. Once I'm done, then we can go ahead and do everything. So now remember, to undo a square root, I'm going to square it. So if I square one side, I'm going to square the other side. All right? So I just told you the square gets rid of a square root symbol. So we're going to have d is equal to, now we're just going to have 55 divided by 4.75, and whatever that answer is, we'll square it. Well, what you should see, and again, it says to the nearest hundredth. All right, so let's see here. When I plugged it in my calculator, I got 134.638. So to the nearest hundredth would be this one here. So I look at the next number, it tells me it's an 8, so I'm going to increase it by 1. So I'll have 134.64. And they already told us the units is feet, so that's what you're going to plug in. Okay. Number 9 is find the inverse of f of x is equal to x cubed minus 5. So remember, on this one here, what they told you to do is they told us to take that f of x, and we're going to call it y. F of x is just a fancy way of writing y. We know that. So now we're going to do this and say y is equal to x cubed minus 5. The next step that they told you to do is to switch the x and the y. So I'm going to have an x here, and I'm going to have my y here, and we're going to have cubed minus 5. So x is equal to y cubed minus 5. And now remember, we are going to solve it for that new y. So to solve it for that new y, that means I'm going to get y all by itself. All right. So first thing I have to do is I'm going to have to add 5. So I'll get y cubed is equal to, remember, I'm taking that 5 and I'm moving it over to the other side, attaching it to the x, so it has to become positive. And once I see that, well, how do I undo a cube? I just told you earlier as a hint. Okay, to get rid of a cube, I'm going to cube root it. So if I cube root one side, I cube root the other side. All right, so that'll tell us our y is equal to the cube root of x plus 5. And remember, your book likes to now change it to g of x. Well, they already put that part, so you don't have to put that. You just have to plug in into big ideas. The cube root of x plus 5. So this is the only part you have to do because I already told you what your g of x is right here. They already have it. Don't put g of x equals g of x. That's silly. Okay, number 10 looks hard, but it's really not because it was one of the first problems we did on this chapter. And all that's telling us is that we have the nth root of a. Well, in this case, our n is 3, our a is 64, and we've done this one a couple times, and you can even just plug it into your calculator. But 4 times 4 times 4 is 64, so the cubed root of 64 is equal to 4, and that's your only answer. Remember, if this one here was an even number, we would have an answer of plus 4 minus 4. Remember, stuff like that. We can have a negative under the radical if the index is odd, but not when it's even. All right, number 11. Let's evaluate the expression 243 raised to the negative 3/5 power. Now remember, we just did one similar to this earlier. So I can write this as 1 over 243 raised to the positive 3/5 power. Okay? So now let's just kind of look at that part right there, because we know we're going to keep it under 1, right? So this 243 raised to the 3/5 power, remember, you can write it 2 different ways. You can write it as the 5th root of 243 and all of that cubed, or you can do the fifth root of 243 and put the cubed underneath that radical symbol and do it like that. So those are your two choices. All right. And this one right here, this one's going to be the easier one. Sometimes you can just see. But the fifth root of 243 is going to be 3. So we're going to have 3 cubed, and 3 cubed is equal to 27. So remember, I told you we still have that 1 on the top, and then on the bottom now we have 27 because we just simplified the 243 raised to the 3/5 power. And that is your answer for that one. Number 12, we're going to give you one more of these just to make sure that you understand this. And this time, again, we're still doing it in simplest form. All right. So on this one here, I'm going to, just like I did with the previous one, I have 4 minus the square root of 5. I can't have a radical in the denominator. So I'm going to multiply the top and the bottom by 4 plus the square root of 5. Because remember now, that's what that's going to do is that's going to make our bottom a difference of squares. So 4 times 4 is going to be 16. The square root of 5 times the square root of 5 is going to be just 5. And remember, it's a difference of those squares. So minus 5. And on the top, we have 2 times 4 plus the square root of 5. In this case here, the other one, the bottom simplified so that we could use it. But on this one here, the 2 and the 11 aren't going to cancel. If you could reduce a fraction there, you would definitely reduce the fraction. But in this case, we can't even do that. So we're just going to distribute that 2 through the parentheses there. So we're going to take 2 times 4. We're going to do 2 times the square root of 5. Remember, when I say 2 times the square root of 5, we're going to put the 2 in front of the radical. So 2 times 4 is 8. And 2 times the square root of 5. And as you can see, what they're going to do is they're going to have you put 8 plus 2 root 5 on the top, and then you're going to put 11 on the bottom. Okay. Number 13, which expression represents 2a raised to the 3 halves times b over 8 times a raised to the 7 halves times b raised to the 1 half. And we want to write that in simplest form. So remember on this one here, what you're going to do is you're going to take the numbers. In this case here, our numbers are 2 and 8. So on this one here, we have the 2 and the 8, and we're just going to reduce that. We should realize that that just becomes 1/4. All right, so if I have no numbers up, any variables up on top, I can't, I have to leave the 1 there, but if I have a variable up on the top, I don't have to. And it looks like by our choices here, we are going to have a number up on top. So let's see here. So remember, when the bases are the same, like right here, my a's are the same, and I'm dividing, remember, I'm going to subtract the exponents. So what I just told you there, when our bases are the same, in this case, our base is a, all right, and we're dividing, so we're going to subtract the exponents. So I'll have 3 halves minus 7 halves. So 3 minus 7 is equal to 4. So that's going to give us a to the minus 4 halves, or a to the minus 2 power. All right. And what that is going to do, again, the negative, that's going to make it go to the bottom. So we'll have a squared on the bottom. Same thing with the b. So if I have the b's there, I'm going to take, when the bases are the same, I subtract the exponents. Well, on the top there, remember that if there's not one there, it's understood to be 1. So I'll have 1 minus 1/2, which will give us b. 1 minus 1/2 is just 1/2. Sorry, I didn't mean to put that equal there. And since that one's positive, that's going to stay on top. So now I'm going to put everything together. So I have a 1 on top. For that one, I have a 1 on top for that one. And on this one, I have b raised to the 1/2. So we know up on the top, we're going to have b raised to the 1/2 power. Well, look at that. It's going to get rid of that one there. It's going to get rid of that one there. All right. And then we have a 4 on the bottom, and we have a squared. So it's going to be that one. Notice how they made it so that we could get rid of one of them right away. Number 14, we just did one just like this earlier too, ladies and gentlemen. So a reflection in the y-axis. And remember, when it's in the y-axis, that means you're going to attach it to the x. So again, we're going to take our h of x, and we are going to say it is our f. And remember, I'm attaching a negative to the x. All right. So our f of x there is 3 to the 4th root of x, but I just told you we're going to attach a negative to it, which is what we just did there. All right. Now I'm going to keep it like that because they just want us to show that it's still going to be there. All right. And then our g of x, we're going to go 5 units down. So remember, that's on the outside. So we're going to say our g of x is equal to our h of x. And we're going to go 5 units down, so that's negative. It's on the outside, so it's minus 5. So our h of x was 3 times the 4th root of negative x. And like I said, we're going to take the minus 5 and put it on the outside. That is how you will put it in your calculator, or one similar. All right, now the last problem here is solve x minus 3 equals the square root of 19 minus 3x. All of that is under the radical. And then it's going to say find the extraneous solution. So what this one here is doing, ladies and gentlemen, is trying to show you both of them. All right. So on this one here, let's go ahead, and I'm going to do it down here at the bottom for you because it's going to be the one that you're going to have to do the most work on. So when I do this, I'm going to take my x minus 3, and I have the square root of 19 minus 3x. So remember, to undo a square, and that's our goal, is that we have to square both sides. Right? So when I square both sides, the right-hand side just becomes 19 minus 3x. The left-hand side becomes x minus 3 times x minus 3. So if you want to do that on the outside here, and if we FOIL it, so our first terms are x squared, our outside terms are negative 3x, our inside terms are negative 3x, and our negative 3 times negative 3 is positive 9, or x squared minus 6x plus 9. And that's what this side equals. All right. So once we get done with that, now we have that x squared, so we're going to move everything over to the left-hand side and set it equal to 0. So I have x squared here, and now I'm going to move that negative 3x over to the other side. When I do that, it becomes positive, so negative 6x plus 3x is minus 3x. And when I take that 19 over to the other side, it's going to become negative. So plus 9 minus 19 will equal negative 10. And we're going to set that equal to 0. So now we're going to factor that. So when I factor that, remember, here's where we remember our little things. So I have an x here, and I have an x here. I look at the sign of the last term. It's negative. I know automatically that one is negative and one is positive. So I know one is negative and one is positive. And what are factors of 10? That will give me 3, actually negative 3. So that would be minus 5 and plus 2. Okay? So then, remember, by the zero product property, you're going to tell me that x minus 5 is equal to 0, or x plus 2 is equal to 0, and we're going to solve those for x. So we'll get x is equal to 5, or x is equal to negative 2. So now remember, what we need to do there is we need to check. So we're going to check both of them, right? If they both work, then there's no extraneous solution. But I'll give you a hint. One of them will be extraneous. So let's just go ahead and check them like I just said. So check. So when I check x is equal to 5, I'm going to plug that into my original equation. So I'm going to say 5 minus 3. And again, this is a question. Does it equal the square root of 19 minus 3 times 5? All right. So the left-hand side, 5 minus 3 is equal to 2. The right-hand side, I'll have 19 minus 3 times 5 is 15. 19 minus 15 is 4. The square root of 4 is 2. So the left-hand side equals the right-hand side. So that one is definitely a solution, right? And we're going to try our other one. So we're going to say x is equal to negative 2, and we're going to plug that one in. So again, I'm going to have negative 2 minus 3. Again, our question is, does that equal 19 minus 3 times negative 2? All right, negative 2 minus 3 is equal to negative 5. On the other side, again, I'm just going step by step. I'll have 19, negative 3 times negative 2 is plus 6. So I have negative 5. Does that equal, well, 19 plus 6 is the square root, is 25. The square root of 25 is positive 5. So negative 5 does not equal positive 5. So this one doesn't work, and it is extraneous. I'll just put extran because I don't have enough room there. So our extraneous solution is x is equal to negative 2. Our solution in this case is 5. That's your test there, ladies and gentlemen. Again, pay attention to this one and you should be able to do fine. All right, thank you and good luck.